auto join option is not coming. Okay, it's okay. So meanwhile, I'll start. I'll just read. Okay. So this is just a demo actually on this Autosar diagnostics. So I'll just brief on this diagnostic. You'll get idea. Is screen up? Can you please? Okay. Yes. Okay. Okay. So start. So just a basic demonstration. So just brief about me. So I have more than 12 plus years of experience, and I just have one thing like if others can add these people, so please keep on adding because I'm not able to go through the screen again and add, so it will disturb. So if you can add some guest, okay. If it is popping up on your screen, please add it, okay. Okay. So I have 2 plus years of experience into embedded software development and Autosar development, and like a BSW stack configuration, more than 7 plus years of experience. Then MCAL also more than 4 plus years of experience. Diagnostics I'm nearly working from last 5 years, and XCP calibration from last 3 years. About NVM, more than 3.5 years I worked on completely purely on the NVM. So where I have configured NVM from the scratch. So this is all about my thing. So generally, what are the prerequisites that we need for this learning AutoSAR is like we should have some embedded C concepts like either pointer structures, bitwise operators. Then we must have some memory data, memory types like we should aware of like a stack, heap, then static, global. So because those variables, those stack things will come always because when you are starting the AutoSAR, always we have to use OS, then we have to use the data segments, heap segments. So things like will be there. Also, if you are talking in terms of diagnostics, always we are pointing data with the help of pointers. Also, there will be some kind of structures also, like let's say you want to read some vehicle parameters. So in vehicle parameters, it can be various parameters. So for that, you need structures. Also, you need a bitwise operator information also. Like let's say if you want to see the sensor status is like whether the status is on or off, or if you want to do some output control, like you have to turn on the actuator or turn on the sensor, or maybe you want to turn on the light, or you want to read the sensors information from the car. So all those things will be needed, like computer structure bitwise operators. Maybe will be like to enhance the memory, like we have to use RAM. Also we have to use ROM, we have to use some no unit RAM sections also. So all those things of information you will get to know when you have a basic understanding of memory like a stack, heap, and static and global. Then you must have some little on the MCU registers, like what are the registers, like a timer control registers, then pulse width modulation. Then we have ADCs, we have PLL, so many things are there. So you must be aware some of the basic MNC registers. So those are related to embedded C. In terms of microcontrollers, you must be aware of any of the family like ARM Cortex M or Infineon or any, or even your STM microcontroller also fine. Okay, I will just try to see. To add all. Meanwhile, if you get pop, then please try to add also. So this is microcontroller basics. Like you must be aware some of the basic things microcontrollers like ADs, timers, and interrupts. Like how interrupts works. Let's say you are running a code and some interrupt comes. How your controller will behave. Then we should know about some clock things and all. So these are some basic things you must be aware of. And in the communication protocols, even if you are aware CAN protocol, that's efficient because our diagnostics will run on CAN. It also run on FlexRay Ethernet, but basic is like you should aware on the CAN actually. So these are the some prerequisites needed. So then Autosar is like just automotive open system architect. So this is like we can say a platform where all automotive organizations are working together, and they are actually trying to build an ecosystem where each and every company will work together, and it will enhance the complete ecosystem of the automotive industry. So all organizations are working like BMW, then Robert Bosch, so many other organizations. KPI is also they are providing their stack. So other organizations also working together to make this thing happen. So mission of the Autosar is simple like we should be a global partnership. We should be have a global partnership and the whatever things, whatever software some normal car companies using. Let's say we have other companies also like Tata. Then we have a Mahindra. All those car companies are there. So while using the stacks, they can use the stacks for BMW also. Also, there might be chance that Tata or Mahindra car has created a good stack of some peripheral or some let's say cyber security related stuff or anything. So those can be can be used by other big organization also. So it's like a common platform. So the one who wants to make use of any stack, they just have to pay the amount or a royalty, and accordingly the each thing will be work. So all issues will be on a standardized level, and we will take benefits of each organization so that our whole ecosystem will be better in a better mode. So it's like that only. So each and every company will be working together to achieve a single goal of vehicle safety, as well as we are also having this self-drive vehicles also. So all those things are coming together to meet the single vision. So these are some basics like which all things are there. Then who all are the partners? Like you see here, all big nations are working towards a single goal like Toyota, Stellantis, Hyundai, Mercedes, all the players are there. So these are just doing fast because I want to dive deep into other things. I don't know why Tato join option is coming. Sorry for this. Then some Autosar partnerships. What all our companies are there in this like doing trips like every organization is there who is looking into this and they are working together to achieve goal. So this is like how I want to highlight more. Like we have two kind of platforms. One is like a classic platform. One is like a auto platform. So classic platform is like whatever we are working on the microcontroller levels, like whatever STM or NSAS or Infineon, whatever microcontroller level works, that we call is a classic platform. And adaptive platform is like that we running on S or maybe some Linux controllers or some we have some TDA4 chips of Texas Instruments. We have some Qualcomm chips. So whatever SoCs are there, like a system on chip or some issues which support the Linux operating system or your display panels or whatever the ADAS features are there. So those features are run on the adaptive platform. And basic thing is like whatever microcontroller things like engine control unit or communications and GPIO controls or sensors mechanism, actuators mechanisms, running of the oil of the engine control, all those things will be done on this classic platform. So mostly diagnostics will be there on the class platform. There will be diagnostics on the adaptive platform as well, but that we will not dive deep because adaptive platform is a separate stream. Even I also don't have experience on that. So generally, classic platform is like mostly depend on the microcontroller kind of things, where we design the issues, we design the like a complex driver design, and so many things we do on the classic platform. So where our whole Autosar resides. So whatever modules are there, like we have BSW model, CAN TP, Ethernet TP, Ethernet interface layer, and so many modules are there. So those all belongs to classic platform. Similarly, in adaptive platform also we will be having uh, some of the same stacks, but it is actually run on the CPP, like C++. In the classic platform, we will only use the C language only, and we have several SIP also that we are getting from various organizations. Like we will be getting with the Vector, some are from the Bosch, some are from other organizations also. Similarly, adaptive platform also we are getting some stacks and all from the other organizations. So what is the Ulcer classic platform? What are the four pillars that I will dive deep? Like a main pillar of the Autosar classic is like we have functional efficiency, functional safety, then we have efficiency, then we have field proven and performance. So if you talk in terms of functional safety like whatever Autosar code that we are using or Autosar stacks we are using, all are functional safety compliance. Like we have a standard like ISO 262 standard. So there we have to achieve the some functionality levels like I should be satisfied the QM or ASIL A, ASIL B or ASIL D. So all those compliance already our classic platform has. So like we have a E2E communication, like end-to-end protection. We have a watchdog, we have memory protection, so that other external world cannot directly communicate with our issue. So there will not be no hacking or there will be no other issues will come if you are using this classic platform because it is end-to-end protected and it's not like if we know the IP address or if you know the issue diagnostics address. With that, it will try to add it or it will try to add some message and use something malfunction will happen. So it is not like happen. So to we have a functional safety, we also have a cyber security attached to it. So this is how it works actually. Then you just got one message like many people are waiting, but I can see here one only, four only. So I'm adding all. Then we have efficiency. Efficiency is like Autosar stack is comes from different vendors. As I like it might come from the Wash, might come from KPIT or so many other organizations are there. So that every company is working together. So there will be a cost effective, and we have a wide range of microcontrollers like what you like Renesas. Then we have Infineon. We do have other ST microcontrollers also. So with that, what will happen is like it's cost effective because every organization is working towards the same goal, and all these definitions, all these requirements are available to all, and everyone can access it freely. So even if you want, like in future, if you want to develop some stack, that development also we can do. And also flexible due to CTD. Flexible due to CTD means like whatever standards are there, it is there. But if you want to write your own code that don't want to follow the Autosar standard, at that time you can write your own driver that we call as a complex driver design. So that option also there. So your application can directly communicate to the hardware with the help of CDD. So you can still create some RT ports and you directly communicate with the hardware. So this is how it is flexible. So it's not like you have to follow the standard only. If you have some time constraint, or if you have some efficiency constraint, or if you want to do some let's say high level of calculation in faster way, or you want to read some actual sensor value at a very fast rate, and if you follow the Autosar standard, for example, it will delay the sync. Then you can use your own driver. So that driver it will directly communicate from application RT and to your directly hardware. Field driven because it has many years of maturity, more than 20 plus years. This Autosar classic platform is there, and it is tested over the last 20 years. Like every car, whatever see on a road is mostly on the Autosar base issues only. So it has a maturity level, so we can trust the Autosar ecosystem because it is like more than 20 plus years we are using it, and it is evolving like 4.1, 4.2, 4.3, and it's keep on increasing the versions of the Autosar, and it has more and more things. Then about the performance, so it's a hard real capabilities, a hard real time. It means that whatever you do, it can be done immediately, and we can run microcontrollers at a rate of 1000 megahertz or maybe 2000 megahertz also. So it's like a GB, and if you want let's say in the normal range in the nanosecond, you can run the systems on several megahertz also. So it's up to the designer's thing. We can go from the 10 megahertz frequency to 1000 megahertz frequency based on the user demand, or based on the how much real system you want, because we have time protection in the OS, we have MPU protection in the OS. So if you differ from the time, even in the 1 millisecond range also, or maybe we can differ in the range of some nanoseconds also, like 100 nanoseconds or 200 nanoseconds, we will get or we will get some trigger like, yeah, this particular task or this particular runnable is not running at a time. So this kind of hard real time capabilities we have in our OS that we are using for this Autosar. And whatever applications are there, you want to do, let's say, do the communication, you want to read the sensor data. It is not like you have to read always. It has to like you have to read in polling way. So we have a event triggered application. Like if this thing happen, you have to do that. Let's say, for example, you are in parking mode. So it will not allow you certain things. If you are in a driving mode and you suddenly you want to reverse the gear, it will not directly allow, because it will see the speed of the vehicle. So you are running at a 50 kilometer per hour speed, and suddenly you put a reverse gear. Doesn't mean like car will travel back. So we have some protection mechanism, we have some trigger mechanism, though. So it will check everything, like what is the engine RPM, what is the speed of the vehicle, whether it is going in a forward direction or reverse direction. All those things will be checked, and based on the events what we are getting in the real time, we are trying to trigger the applications relevant into the issue. Like let's say you are going into the production mode, then calibration will not support. If you are going into the field mode, then it will not allow to write some data into the ECU. So those are like a event triggered application. So if you are in a developer mode, then it will not allow you to delete the DTCs. If you are, so we have so many things which are based on the whether your car is in production mode, in the development mode, or in the field mode. So based on that, it's a event triggered applications. So accordingly it will behave like what actions need to be done based on the events. Then it is a flexible because it has a wide range of protocols. Like let's say it supports I2C, CAN, it supports UART, SPI, so many protocols it will support. Then lean also we have for if we want to communicate with the normal modules which doesn't have more intelligence, then we can have a lean model like for door control and all. If you want to have a fast data communication, you can use the Ethernet also. Can, so many things are there. So it is flexible, and it will allow to do how much things it can do. It will allow that. So that is why it will be like flexible. Then it is a scalable by configuration. Let's say now you want to do the two CAN channels. If you want to add more CAN channels, so you just have to go to the configurator, and after going to the configurator, you just have to double click the containers, or you can copy the containers as well, and accordingly it will behave. So we need not to do everything. We need not to do every time everything. Okay, like we have to do the code from the scratch. If we want to do everything from the scratch, it's like a double container type. Okay, like just copy paste the container and everything will be done like that. Then next will be like some of the Autosar basic principles. So Autosar basic principles is like simple. Like we someone is using, let's say, this platform, someone using other platform. We we want to develop a car. So we cannot give the all implementation to one organization only. So for that reason, what we will do is like we will divide the suppliers. Like a supplier is very much good in, let's say, radars and all, then we will give them this kind of implementation, like radar related stuff they will do. Some are more into this chassis and safety or telematics, then we will give this to them. Some are more compatible into this body comfort and powertrain and telematics, so we will provide this particular things to be done with the help of this particular supplier. So it's not like we have to do each and everything from only one customer, or maybe not customer. We will call it as a supplier, because you as a OEM, let's say you are a car maker organization, let's say BMW. So BMW will divide the work with all the organizations, and they can work independently. And once everything is done, then once everything is done, then integration. This OEM will do the integration. So this is how this Autosar basic principle works. And each and every time what happen is like you want to develop certain systems, you will create some software components, like some automatic software components or some modules. So based on the suppliers expertise, we will request those modules to be given by suppliers, and then at the end we will do the integration. Also, whatever supplier is there, it might be having already so many modules ready, or we also have some modules ready already. So then they can directly reuse it, and our complete development phase will be faster, and it can be done. Means our time to market will be very less. So this is how this Autosar basic principle works, where all companies, all organizations work parallelly, and they can achieve the goal very fast rate. Then this is some architecture, like you might be all aware, but I'm just briefing it. Like we will be having some, we call it as Autosar as a layered architecture, because it has various layers like application, we have RT, we have service, ECU abstraction, and microcontroller abstraction. So I'll tell you one example. Let's say you are a car manufacturer, you are using, let's say, one microcontroller. Example, you are using some Infineon microcontroller, and that microcontroller is in end of line. End of line means that microcontroller is going to that company is going to shut down, or maybe they will stop manufacturing that particular controller. So in previous way, what will happen is like we have to do complete change. Like we have to change the application middleware. In previously, I'm saying microcontroller, you have to change. You have to change so many configurations, so many updates you have to do. But if in the Autosar layer widget, what will happen? Let's say your microcontroller got updated. So in that, what will happen? This microcontroller is got updated. Then what will happen is like you will just change the controller, and you just change the MCAL abstraction layer provided by that microcontroller, and then our application, RT, service, and ECU abstraction will remain same. So though hardware will change, but your what we can say, your code will not change. Your application will be like that. Your RT will be like that. Service layer also will be like that. Only your MCAL abstraction will layer change, and with that there will be a small modifications, some small configurations you might have to do, and with that our code is ready to go with the new controller. So with the Autosar layer architecture, what happen is like we are become hardware independent. So we will not be having any hardware dependency with any of the microcontroller, and we can write our application. Another point is like, let's say, I will talk in another way now. Let's say you want to work on the system, but your board is not ready. Your actual board that you want to work is not ready. So what we can do is like, we will use just microcontroller evaluation board or microcontroller development board only, and we can do all the testing. Once our testing is completed, we can directly switch to the real production board. So that feature also will be available with this Autosar layer architecture. And sometimes what happen, you are expecting some microcontroller, you are, let's say you are in a development phase. Right now you are, let's say, using one microcontroller of STM. Later you found out that after 2 years or 5 years, like this microcontroller is there, it is good, but it doesn't have a very good things, and you want to do some software updates and all, and the memory is not sufficient to do the software upgrades or updates. At that time, what you can do, you can directly change the microcontroller by just replacing the MCAL and microcontroller. So that upgrade facility also will be there. So, but in older mechanisms, we don't have that kind of facility. So with that, we stuck a lot. So maybe due to that, this Autosar came into picture and this layer architecture works. Additionally, if you think like whatever flow we are doing, like it is coming from application, RTE, service, issue, all layers it is coming, and you feel like this is a time consuming, Autosar do support this complex driver design also. So where you'll just write your own software component, you create, let's say, CDD underscore your own application, you connect the ports to RT, and directly from complex driver design you can reach to the microcontroller. Let's say you want to read some PMIC pin, some over voltage or under voltage things you want to check, or some airbags related stuff you want to check, then you don't have that much time to react. At that time you directly check with the microcontroller, we connect with the microcontroller with the complex driver design. So that option also provides, and with that what will happen is like, your code will become modular, and everything will be done as per your need. It's not like uh, uh, the whatever Autosar is providing, you have to do like that way only. So you can use your own things, you can improvise the things, and you can good to go ahead with your own ideas also. So that is how flexible Autosar is. This is just a little on what is there inside the application layer. So like we have this system services. In the system services we'll be having OS. In the memory services we'll be having NVM. Communication services we'll be having COM, CAN, NM, like that way. Then we have this IO hardware abstraction layer to read the IO hardwares, and then complex driver design. It's like just a code snippet that will be helpful for doing the complex driver stuff. Then onboard device abstraction will be there. We have memory hardware abstraction layer. We call it as a P model, flash memory related stuff. Then we have communication hardware abstraction layers, like we have CANI for Ethernet, like that way. And here I hardware is like a IO hardware only, like it's a kind of a MCAL. Then in communication drivers we will be having CAN driver. We have Ethernet driver. All those things are there. In memory driver we'll be having FLS. In microcontroller drivers we have their own microcontrollers, timers, counters, like that way. And then at the bottom we having a real microcontroller. So this is how it works. And OS is like a main in this complete Autosar. So OS has to communicate, it has to map the functions, runnables, and periodicities of tasks. All things will be taken care of by the OS itself. It's like a heart of the our Autosar. Then again, it is dive deep what I mentioned earlier, like saying like NVM. Then we will be having this memory abstraction layer. It has a memory. Then we have some memory drivers. Here in the microcontroller drivers, we'll be having watchdog. We have a MCU. Then we have a GPT for timer. All things are there. Then here we will be having Autosar OS. We have Diagnostic Manager. We have DET, Diagnostic Control Code, DLT for logging. So many models will be there. So it's not like if you want to be Autosar developer, it's like only you have to be in this all models has scope. You can stick to one model and you can continue on this. Like you can continue on the communication services itself or diagnostic services itself, or you can be a master in the memory services itself. It's like a huge. So based on thing like at least on one thing you have to work 2 to 3 years so to get a master on it. So it is like that. So basic understanding you must have, and then as per the standard, at least at like a diagnostics or if you are aware of, then you are to go with the other organizations where data server will be there. This complex driver doesn't have anything because it's like a own manual written code, and it depends on how you write like that way. So here we don't have any model. It is same only what is main, but in some good manner. Like we and the application will be having several applications. Like we want to read some temperature or ECU or thermal degradation or anything like. You want to read the temperature of the car. You want to read the vehicle of the car. All this application components will be there. You want to do some diagnostics. That component will be there. So many applications will be there. Then you will create some ports to communicate to the layer. So RT is like runtime inverter, a runtime environment where it will do the connections between the below modules. Also, another thing is like most of the organizations will be having separate BSW team and separate ASW team. We call it application software developer. So there, what happen? You can do the application team and do their work irrespective of BSW, and BSW team also can do work irrespective of application layer. So we will create some VFB virtual function bus. With that, we'll create some dummy post. Let's say you want to, let's say application want to read some data. So we'll give some dummy data via VFB. Or in another way, in the BSW levels, let's say, in the BSW level, you want to get some commands from the application. So that dummy things we can do with the help of VFB, virtual function bus. And each team will work independently. Like BSW team will focus on the configurations and implementations related to the Autosar standard. And application team will do the application stuff like logic implementation, business logic implementation, what actions to be taken, which models to be turned on, turned off, or maybe what values to be passed to the below layer, what values to be taken from the below layer to upper layer. All those things like an independent team can work, and with that, what will happen? Like we will be do all things together, and at the end we can integrate. We do the integration of AW and BSW, and things can be faster. So this is why this layer architecture play a role. Assume like MCAL team will be different. We have OS team that is different. Diagnostics team will be different. Memory services like we'll be having different teams. So each team will work together because they have different ARXML. And whenever RT comes into picture, they have to like do together. But whatever level configurations or the BSW level configurations, that all configurations will be done with the help of independent team only. So that is how this layer architecture will help to build the system together in faster way. So I just want to show you this basic flow, like what will happen. This time giving on a high level, but if we will dive deep when our actual thing starts in the course. So like let's say tester is like any tester, like it can be a tester from the service, or you can be a developer who wants to test something. So these are some DIDs, like a 10 means it's a SID, service ID. Then 03 is like extended session. So if I test as in 10.03, then it will be an extended session. So we'll get a response from the ECU like 50.03. So what happens is like whenever you want to some request, and whenever you get a response, it will add 0x40 in the response. So that's why 10 become 50, here 27 becomes 67. So it's just an indication like that ECU is responding. So whatever we send the request, ECU will add plus 40 in the hex, so that it will be considered as a response of the particular SID. So like a 10.03, it will be 50.03. 27.07 is like a 27 is a security access related service. Then we will get a response like a 67.01. Then some CD will get. Similarly, I'll send 27.02 with the key. Then we'll get a 67.02 access granted. You want to read some DID. DID is like a diagnostics identifier. So each data of diagnostics will assign a unique for like a unique 16-bit number, and that unique 16-bit number is like any number that is you have to define in your Candela file, or it has to be agreed between you and customer. And then we will be having some standard DIDs also, which agreed and accepted overall the UDS standard, like 14229 is the UDS standard. So that also it is possible. So based on the DIDs that we have with the customer, or we can have some proprietary DIDs also with respect to your own implementation. So those numbers we have to give accordingly. The implementation has to be done in the code. So how this implementation will work, how if what will happen exactly when we send a request, which all APIs get involved, which all modules get involved, how data flow. So those things obviously will be a part of discussion that we will cover in the upcoming sessions. Then this is just a simple flow. I want to explain how exactly it happens. And one more point to remember is like whatever communication happens between the ECU and tester, it will be always done with the help of transfer protocol, because whatever data we are sending, it will be always more than 8 bytes. And generally, we have to give the buffer size of the diagnostics, so that we always give like either 1024 bytes or maybe 4096 bytes, based on how much payload or how much data that you want to send or receive from the uh, ECU, or maybe to send to the ECU, like that way. So that's why it always more than 8 bytes. So if it is can, it is always more than 8 bytes only. And with the Ethernet also, it will be always more than 1400 bytes. So everywhere we have to use TP only. Only the TP may will change. Let's say if you are using the CAN, it will be CAN TP. If you are using diagnostics, it will be like a DYIP, like a diagnostics over IP. If you are doing with the CAN, it will be diagnostics over CAN. If you are using Flex, it will be a diagnostics over Flex. It depends, but only at the end, everything, whatever you are communicating or whatever you are doing, it will be always done with the help of transfer protocol. So I just want to give brief like how it works. Like CAN TP will be like it will always done with the help of frames. Like we will be having four types of frames here. One will be single frame, then first frame, then consecutive frame, and flow control frame. So in the first byte, we'll be having two parts. Bit 0 to bit 3 will be like detecting what is the data, or sometimes it detect the sequence number. It sometimes give the flow control details also. And in the higher nibble of the first byte, it will detect like which kind of frame it is. So type equals 0 means, yeah, it's a single frame where you want to send data which is very less, but still as we are using transfer protocol, we have to send the data. So that is a single frame. We plot data in the range of 0 to 7 bytes. So it will do, it will be 0, then here it will give the length and it will send the data. In the second type, we'll be having first frame where you want to send the data more than 8 byte or maybe more than the threshold defined. So if you want to send more than 8 to 4095 bytes of data, then here first like higher nibble of the first byte will be 1. Then here lower 4 bit and the another 1 byte means it's a 12 bit. So 12 bits means 2 raised to 12. So it's equal to 4096. So we have to give the details like how many bytes you want to send. So that length we will set in the higher 4 bit and the first byte of this particular frame, and then data will start. Then we have consecutive frame. Consecutive frame is like a higher level of the first byte will be type 2, and his sequence number it will range from the 0 to 15 because it's only 4 bit. So once it reaches to 15, it will reset to 0 and it start interpreting like a sequence counter, like which block you are sending. Is it the first block, is it the second block, third block, or like that. Accordingly, it starts sending it, and accordingly it will that sequence number will be validated on their side. Here we have a flow control frame. Like flow control frame is like I want to send data, but we want to know whether receiver is there, whether receiver is ready to accept the further frames or not. So for that, flow control frame will be sent by the ECU. So at that time, byte here will be 3. Then here have some control flags like a block size, then this separation time and flow control flag, like that way. So here what happen is like if block size is 0, it means it will ready to accept all the blocks. If and the separation time or ST mean is like how much time it will take to send a consecutive frame, like, or maybe at what time second frame consecutive frame should be sent. It can be a 10 millisecond, it can be 5 millisecond based on the configurations. So what will happen is like it's based on that. So if it is 10 millisecond, every 10 millisecond our EC will send the frame, or maybe receiver will accept the frame. It is like that. And then further bytes will be any. So only byte 0, byte 1 and byte 2 will be there. So this is how transfer protocol work. We will dive deep whenever we will be having further sessions. But right now this is the state where basically how TP works is like this only. So it can be any protocol, but frame format will be same because it follows ISO 15765-2 transfer protocol standard. So it's a standard. So medium can be any, but the things will be same only. So this is all about the today's session. I'll just dive deep into the details of the course. Like so, it is like we are planning to start on the 3rd June, and we are planning to start with the 20 students only because if more students are there, we are not able to focus on each student. Okay, then it will be like a 20-hour live, and it is like even if you have a only embedded C experience, you can be a Autosar developer. That is the thing. And even if you have Autosar experience, you will again become expert. So even if at any level, it will be applicable for all. So thing I'm covering is like a complete standard 14229. What it is like, whatever services are there, everything will be there. Then configurations, what all configurations will be there, like a DIDs, what are the sessions, then how mapping will be happen, everything. Then we will be having DEM configurations like what all DCs, what event handling is there, what is freeze frame, what are snapshot, all those things are covered. NVM integration, how these diagnostics events or DIDs will store into the NVM, or you want to say send a request to read the data from the NVM, how it happens, everything covered. What will access, how it will protect the data. Some practical examples are given. Routine controls, what is routine control, what is DID, what is RID, those things will be there. Some couple scripting example I'll try to give, and then some troubleshootings like what issues can be, what bugs will be. Some practical case studies I'll try to cover. So included with a no cost is like whatever sessions we are going will be recording. So all these video will be given to you. Some handwritten notes, some Q&As that is mostly asked in the interview. We'll be having one-to-one doubt solving sessions per person, two, like whoever joins, and those record also we'll do. So let's say 10 people join, then 20 hours of recording additionally I'll share to everyone. If 20 people joins, additional 40 hours of downloading sessions will be there. Then we have some mock interviews. Not sorry, this is something else. This mock interview, like it depends. Like you are confident, you become confident, and you want to have mock interviews. Then we can schedule the 2 mock interviews per person. Then some diagnostic clips, some guidelines if you want, some sample XML, some sample code snippet. So that also I'll try to provide. So these are all things there, and fee structure will be like if you want to book a seat. So we, as we are accepting only 20, so if you want to book seats, you can by paying this 3,990 rupees, and our total fee will be this 9,999. So this is how the things will be. I will share these details on the group chat, and if someone interested, they can do. Additionally, you all are aware like DaVinci developer and configurator will not be available, and obviously I'll also don't have, I'm not the person that I have those things, and it will not allowed also. So I have one tool, okay, custom tool. So it is not this one DaVinci or anything, but this tool, additional tool also I'll provide you. So with that you can do the configurations. It will mimic the diagnostics. It will not generate ARXML, nothing. It will not generate code also. It will generate the ARXML, but you will just get an idea like how BSW models are there, how DEM configurations will be there. It will try to mimic the things, but it doesn't have all things. Let's say DSD services, receive resets, all those things. You can add, you can do the modification, you can do the trial and error testing. It's nearly 90% it will follow the standard because it's not exactly what Autosar is, but it will cover most of the containers. You can add the containers. Let's say you want to do the configuration, it will, let's say OBD DTC you want to add, it will do that. Most of the things it will try to do. We have peak configuration, how PDR works, what is the destinations, what are the upper model, higher model, what is the routing path you have to select, so engine temperature, or how you can add it in ACUC. So all those things you can learn here. We have OS configuration, ADC configuration. So all these things you can do dive deep on your own. But I'll try to cover all the DCM, DEM, NVM, and some of the PDR Yeah, I'll try to cover some of the CAN TP, CAN interface layer because these are needed because our diagnostics will travel from the below layer only. So accordingly, I'll give this access to you also. You can try to access this and you'll get benefit of it. So it will try to mimic 90% of the DaVinci configurator because we will not in no one will have DaVinci configurator or any other tool. So this is like an equivalent tool which will give a benefit of learning and get a feel of configuration. So that's all about. If anyone has anything, you can we can have a discussion over a chat, and I'll send one form there you can apply and you can try to join the course. So that's all from my side. Thank you for taking all the time and investing time on the Saturday. Thank you very much.